Hello everyone, in this video we're going to be solving a functional equation. If you like this video, please comment, like and subscribe, hit the bell button for notifications, and let's get started. So we do have a functional equation, f of x squared multiplied by f of 1 minus x divided by 1 plus x, and the product is equal to x. And we're solving for f of x basically, under certain conditions of course, because for example x does not equal -1, because otherwise it's going to be undefined. So under those conditions, how can we solve for f of x? This is an example of a functional equation, and I don't think in this channel we've done a functional equation before, so this is the first time. I'm very excited. And I just want to let you know, tomorrow we're going to be making a video on Diophantine equations where I kind of explain some of the techniques and strategies and also give you some good examples. All right, awesome. Now, to be able to solve for f of x, we're going to do a couple of manipulations here. One of the things that you need to notice with this expression is that 1 minus x over 1 plus x is a rational function. So it's kind of like a f of g of x, right? Where g of x can be written as a rational function. So that's an important fact because this rational function is not an ordinary rational function, but it's a special type of function. Why do I call that special? Because if you invert that function, what are you going to get? You're going to be getting something nice. Let's go ahead and take a look at it. So let's explore that first, and then I'll talk about how we can use it in our solution. So the first thing I'm going to do is I'm going to try to find the inverse of this function. So I'm going to set it equal to y. And then what I'd like to do is basically replace x and y, or switch the roles so that I can write x as a function of y, and then you can safely say that it's the inverse function. Okay, cool. Let's go ahead and cross multiply here. 1 minus x is equal to y plus yx. Now, since my goal is to solve for x, I'd like to collect all the terms together. Anything that has x in it, I'm going to put it on the same side. So I'm going to go ahead and add x to both sides. That's going to give me yx plus x, and then I'm going to subtract y from both sides. That's going to give me 1 minus y, obviously. Then I'm going to take out the x. Basically, I'm factoring here. X times the quantity y plus 1 is equal to 1 minus y. And if you divide both sides by y plus 1, you're going to be getting the xy in terms of y. Okay, so 1 minus y divided by 1 plus y. And what is that supposed to tell you? That when I solve for x in terms of y, basically this could be called f inverse of y, right? So x is written in terms of x inverse of y, and then f inverse of y. If you go ahead and replace x and y here, kind of switch them around, you should be getting the f inverse of x as 1 minus x over 1 plus x. What is that supposed to mean? Wow, f is a very special function because its inverse equals itself. Now, what is that supposed to mean? It means that if you replace x with its inverse, then you get the identity function, which is f of x equals x. Okay, what is that supposed to mean? It's kind of confusing, right? Well, this is what I'm trying to say. In this functional equation, I'm going to replace x with 1 minus x over 1 plus x. And when I do that here, that's going to give me x. You want to see that in action? Let's go ahead and do it. So I'm replacing x with 1 minus x over 1 plus x everywhere. So that should give me something like f of 1 minus x over 1 plus x. And the whole thing is obviously squared, multiplied by f of this expression. So let me go ahead and just plug it in to see that we're going to be actually getting x from there. So I'm going to replace x with 1 minus x over 1 plus x. Here and here. Okay, that's what I'm trying to do here. Okay, cool. Let's go ahead and do that. And then from here, we should get something simpler. And of course, on the right-hand side, I don't have room to write it, but this should equal 1 minus x over 1 plus x, because you basically need to replace x with this everywhere, right? On the right-hand side as well as on the left-hand side. And again, under certain conditions, this will be satisfied. Okay, now, what do we get from here? Well, first of all, we get f of something squared, which is kind of similar to the original one, but let's go ahead and write it down. But here, we're going to make a common denominator, or we're just going to simplify it. Now, how do you simplify it? You know, there's a couple ways to go about it. One method is multiply the top and the bottom by x plus 1, of course, assuming that, you know, here and here, assuming that x does not equal -1. So if you do that, I think that's gonna be the shortcuts, sort of. You're gonna be getting 1 plus x minus 1 minus x, which you can write as -1 plus x, divided by, at the bottom here, you should be getting something like 1 plus x plus 1 minus x. Cool. And the right-hand side is going to equal 1 minus x divided by 1 plus x, because remember, we replace x with 1 minus x over 1 plus x. Make sense? Hopefully it does. Now, we got another equation which kind of seems complicated, but guess what? This can be simplified. And trust me, it's going to be real nice when we do. Okay, so x minus x can be simplified. 1 minus 1 is equal to 0. Beautiful. Now here we get 2x divided by 2, which is equivalent to x. That's what I was talking about. So when you replace x with 1 minus x over 1 plus x, we got f of x from there, because those functions are inverses, or this is a function whose inverse equals itself. Okay? Or you can call it periodic, whatever. There's so many ways to call it. So anyways, this becomes f of x, which is nice. Okay? And then we get this. Cool. So, well, what's so cool about it, right? Well, here's what's cool about it. We're going to look at this expression. We have the f of something squared multiplied by f of x. If you look at the original one, you get f of x squared multiplied by that thing, which is f of something. Okay, so let's go ahead and write down the original problem here, and then we're going to look at it as a system of equations, okay? So my original functional equation was f of x squared multiplied by f of 1 minus x over 1 plus x, not squared, right, equals x. Okay, so this was my original problem. So remember, we're trying to solve for x, or f of x instead. How do we get rid of the other expression that is kind of complicated looking, right? Well, one thing you can do is you can go ahead and square the second expression, which happens to be the original problem, by the way, right? So we can go ahead and take this and square both sides, and then let's see what we can do about it, right? Let me go ahead and do it, and then I will just show you what we're going to do from there. So I'm going to go ahead and square both sides of this, and that should give me f of x. Well, now, here you already have f of x squared, so be careful about that. It's going to become f of x to the 4th power, right? Multiply by f of 1 minus x over 1 plus x. By the way, you might be asking, like, why are we doing this, right? Why am I squaring both sides? Because my goal is to get rid of this term, and notice that it's f of 1 minus x over 1 plus x squared. If I square the second equation, I get the same thing. Then I can hopefully get rid of that. How? Well, if you square both sides, you're going to be getting this squared, multiply by that to the 4th power. So this squared times this squared equals this squared, and that is equal to x squared, right? Cool. Now this is my original problem squared. Now I'm going to go ahead and take that and divide it by the first equation, which is this one, okay? What happens if you divide this by this one, f of 1 minus x over 1 plus x squared times f of x. Nice. Now, when you do the division here, let me go ahead and erase this. Okay. So this is basically going to equal, I guess I was erasing it, right? Didn't I? Okay. So when you divide these, first of all, notice that these two terms are going to cancel out, leaving us with f of x to the 4th power divided by f of x, which happens to be what? F of x cubed, right? So we get f of x cubed from the left-hand side. What do you get from the right-hand side? Well, we are talking about a quotient of two equations here, and the top is x squared, because this was x, remember? We squared it, so that this is going to be x squared divided by, right? Divided by the first equation. When, remember, we didn't do anything to the first equation, this one, we just wrote it. So it will be divided by that, 1 minus x over 1 plus x. So this is what I get from the right-hand side, okay? We divided the second equation by the first one, and this is what we got. Cool. Let's go ahead and simplify this. How do you simplify this? Well, I can just go ahead and flip this expression here and multiply by x squared. That should give me x squared times 1 plus x divided by 1 minus x. And since I'm looking for f of x, right, and again, in this case, x cannot equal 1, right? You can safely say that. And we get the f of x by cube rooting both sides, right? Is that a word? Is that a word? I believe so, or we made it one. So we can go ahead and cube root both sides, and we're going to be getting f of x equals the cube root of x squared multiplied by 1 plus x divided by 1 minus x. That's f of x, and this brings us to the end of this video. Okay, tomorrow you'll see a video on Diophantine equations, or some people say Diophantine. I think they're both fine. And until then, take care, be safe, and bye-bye.